Still working on making sure I'm up. Are we here? Still working on making sure. Yep. All right. Listening to myself back 10 seconds later to make sure. Okay. Hello. Making sure that writes. And then we'll start. Okay. Yesterday we left off by talking about surface area, and that was the more complicated piece. Today we're going to do volume, and it's going to be quite a bit easier. Then we'll talk about some circle stuff. We'll go back to some similarity stuff that we did at the start of the year, and then we'll be done. Then we will be done. Okay. Here we go. Here. All right. So we have, I want to walk through real quick what we've got to find the volume of. We have a cone. We've got a, that's a square pyramid. This is a sphere. And this would be a cylinder. All right. Now the cone and the square pyramid, the cone and the pyramid are both going to have the same volume formula, which is 1/3 the area of the base times the height. Right, because it's based on our same type of formula. And then the cylinder and the prism have the same basic structure of the formula, which is just area of the base times the height. So just like yesterday, we're going to start, whoops. No. Here. We're going to start with our area of the base formula. Area of the base. This is a circle. So that's going to be pi r squared. So pi times our radius squared. Well, our radius, don't forget, it starts, this is where we left off yesterday. It starts halfway across and works its way across. So pi times our radius here is halfway across, which is 10 squared. So that's 100 pi. And then our height, we talked about our slant height scaling us up the pyramid. And I've talked about my height being dropped straight down into the center of the shape. That's the height of a pyramid or a cone. All right, so our height is 20. So then our total volume is 1/3 area of the base times our height. Well, area of the base we found was 100 pi. And our height we decided was 20. Let's see, 100 times 20, that's going to be 2,000 pi. And then we still have a 3 on the bottom. All right, so we can go to our calculator and figure out, since it wants us to round, so we have 2,000 pi. Here, I'll take this away so you can see better. 2,000 pi second pi. And we want all of that divided by 3. Boom. 3 decimal places, so 2094.395. inches cubed now. Cubed because it's a volume. Volumes in units cubed. If you're not seeing how it's units cubed, remember that it's we did pi r squared for our area of the base. So we have inches squared times the height makes inches cubed. Okay, next. Our square pyramid. 1/3 area of the base times the height. Our area of the base... area of the base, it's a square, so it's just side squared. So that is 10 squared, which is 100. And our height, remember our height just drops perpendicular down to the center. By the way, our slant height, if I were to draw slant height, it would be up this way. This would be slant height. But this is my height. It's 7. Okay, great. So let's plug that in. Volume is 1/3. Area of the base times our height. Area of the base here is 100 times our height here is 7. And so we have the exact answer is 700 over 3. Which I don't need the calculator. That is that should be 233, or here. Let me go over here so you can see it better. 233.333 inches cubed. Still inches cubed. I'll come back to the sphere. I want to keep on the same track. So we're going to do the cylinder next. Sphere is a bit of a different formula. Cylinder. Cylinder, just like with surface area, the formula for volume of a cylinder is the same as a volume of a prism. So a triangular prism, rectangular prism, whichever. Area of the base. Pi r squared. Pi times our radius is 12 squared. Our radius is 12 because, again, we're going halfway across. The 24 that we're given is a diameter. Diameter goes from one end of the circle all the way to the other. So if we want the radius, which is halfway across, we're going to cut that in half. So pi times 12 squared is 144 pi. Our height is just the distance that connects the bases. So connecting the bottom circle to the top circle, that would be 8. So then for our volume formula, area of the base times the height. Area of the base is 144 pi. And our height is 8. I'm going a little bit quicker because this is kind of more straightforward than the surface area stuff we were looking at yesterday. Plus, if I lose you somewhere, if you missed something, then you can always go back. That's the nice thing about doing things this way. This I do need my calculator for. So let's 144 pi and then times 8. There it is. So we should get approximately 3619 0.1147. So we're going to round that up to 115 miles cubed for volume. Okay, volume of a sphere. I'm not going over the formulas too in depth because if it were a test, I would be giving you the formulas anyway. You would just have to look, oh, it's a sphere. What's the volume of that? It's here. And even on something like the SAT, when you go and take the SAT, they're going to give you this formula. Volume is 4/3 pi r cubed. So the only thing we really need to figure out is the radius. This time, they're nice enough to just give you the radius instead of you having to worry about the diameter and cutting it in half. So the radius is 2.9 equals 4/3 pi times our radius cubed. So our radius here is 2.9. And now let's go to the calculator. I'm actually going to show this one because it's a little more complicated to put in a calculator. Here, and we're going to hide this. So we have 4/3. I always put fractions in parentheses. Always use parentheses for fractions. 4/3 times pi times, I'm going to use parentheses here. What was our radius? Our radius was 2.9. Cubed to the third power. And we're going to close our parentheses. And this way, it should tell us our answer. 102.160. So that equals... Uh-oh. This wasn't as clean as I thought it was going to be. 102.160. 04, so we round it down to 0. But I'm still going to give 3 decimal places so that we know that we're rounding to 3. 0.160 yards. What? Why did you switch pens? There we go. Yards cubed. This is the most I'll have on screen at the same time. This is getting messy. Leave it up there for a second. Make sure you have it written down. If I get rid of it too early, you can always go back. So let's move on. All right. We already did 25 yesterday. Regular polygon, you're using 1/2 ASN. So if you missed it, go back and watch yesterday's. We did it near the end of yesterday. Okay. Fantastic. On to circles for a little bit. We're solving for x. We did these a couple weeks ago, so hopefully it should kind of be in your mind. What we are looking for is either to go all the way around the circle to make 360 degrees, or to find a diameter that will take us halfway around the circle. And glancing, you should be able to see that we're not going to use all the way around the circle. Why? Because we don't know this and we don't know this. So that's not going to help us. Okay, we actually want to find a diameter. So find a diameter where we know everything. Diameter that's going to help us here is here. Because we actually have every piece of information. This is 105. And then here's the 37x plus 1 that we're trying to solve for. So we have 105 plus 37x plus 1. And that adds to 180. Why 180? Because we're going halfway around the circle. All the way around is 360, so halfway around is 180. 105 plus 1 is 106 plus 37x. And now we just need to solve the equation. We're going to subtract. And it just so happens that it divides out nicely, and we're going to get 2. There we go. Done. So on those problems that we did, if you hadn't done that central angles worksheet, that's just a reminder of how those go. Most of the time, you're either looking for halfway around the circle or all the way around the circle. Okay, next. This way. Find the length of the arc, find the area of the sector. So here's how these are different. We're going to have exact answers this time. We're not going to round. All right. Length. We're starting with arc length. Equals part of the circumference. Hopefully what we remember from, this was last week, so hopefully what we remember is that arc length is going to be related to circumference, and then area of the sector is going to be related to area. So let's do it. What color? I can't remember what color I used for what. So we'll do this. Part. To get our part, we're asking how far around the circle did we go? Well, all the way around would be 360, but we're only going 270 around. 270 degrees around the circle. So we want to take that out of 360 and reduce that. I'll tell you that this reduces to 3/4. So we're going 3/4 of the way around the circle. And then we want circumference. Circumference is 2 pi r. So that's going to be 2 pi times our radius. Our radius here is 3. So that's 6 pi. So what we're finding here is the distance. If I were to unwind this arc that I just traced out, what would its distance be? Length equals, we have our part times our circumference. So our part, our fraction, is 3/4, and our circumference is 6 pi. Okay, let's see if we can cancel any fractions. Oh, we can. These are both divisible by 2, so 3 on top and 2 on the bottom. So we're going to get 3 times 3 on top is 9 and a pi over 2. There's our arc length. Now for the area of the sector, sector is going to be the same thing except related to area. So part times area. And our part, we've already found, it's still 3/4. We're still going 3/4 of the way around the circle. Area of the sector would be, what's the area of this shaded part? Pretending that I shaded the whole thing. Okay. Area. And it should be that fraction of how far around the circle we went. Last week, I sent out a nice little activity that should give you kind of an idea of how this looks. But it's going to be pi r squared. The whole area is pi r squared. Pi times our radius is 3 squared. So 3 squared is 9 pi. So that means our sector is part times my area. So that's going to be our part is still 3/4 times the area was 9 pi. Again, hopefully this should make sense that when we're doing this, since we're going 3/4 of the way around the circle here, we want to take the area, the total area, all the way around, and take 3/4 of that to figure out what the sector is going to be. 9 times 3 is 27 pi over 4. Nothing cancels this time. That's as reduced as we can go. Next, all right, we're just we're doing the same process, exact same process. All right, our part is 315 over 360, which, if I remember right, let's see how that reduces. That should be, yes, that should be 7/8. Yes. Yes, 7 over 8. So we're going 7/8 of the way around the circle. So almost all the way around, but not quite. And then our circumference is still 2 pi r. Circumference is 2 pi times our radius is 9 this time. So that is 18 pi. And so to find our length, we're going to multiply those. Our part that we went around the circle is 7/8 of the way around. And so we're going to take that fraction of the whole circumference to get our arc length. Again, we're going to see what cancels. Let's see. This is divisible by 2. This is divisible by 2. So 4 down here and a 9 up here. 9 times 7 is 63 pi over 4. Boom. And so for our sector, we're still going to use the same fraction of the way around for our part. We're still going 7/8 of the way around. But we want to use the area this time. Area equals pi times our radius squared. Our radius here is 9 squared, so that's 81 pi. So the sector is going to be a fraction of that. Instead of going all the way around the circle, which would be 81 pi, we're actually going 7/8 of the way around the circle. So we want 7/8 of that total area. Let me double check my work here. Yes, 567. 567 on top, and a pi, and an 8 on the bottom. There we go. By the way, our lengths would be in units, so inches, and then our area of a sector would be in inches squared. And just to make my brain feel better, let's put a box around this one too. There we go. Now I feel better. Okay, let me pause here to get a take a quick drink of water, and then we will get through the rest of these here. We've done the ones that take the longest, so the rest of these should go by quickly. Yeah. Okay. Similarity. This has been a while. This has been a couple months. All right, so quick rundown. We have 3 ways to prove similarity. We have side, side, side. We have side, angle, side. And we have angle, angle. And this is all for similarity. That was the symbol for similarity. And what we did was we figured out which one we were going to use. So for example, on this one we're going to use side, angle, side. All right. And we have, let's see, we have angle BCA being congruent to angle LCK. And the reason we know those are congruent is because of the vertical angles theorem. Vertical angles are congruent. So one more real quick thing. We want angles to be congruent, and we want sides. Let me try that again. We want the sides proportional. We want the ratio of the sides to be the same. That's what we were checking for. And if something doesn't match, then they're not similar. Okay, so we have vertical angles. And now we're going to check some ratios. When we checked these, what I always said was check the smallest side with the smallest side, medium side with the medium side, and largest side with the largest side. All right, that's how we can find and set these up. So we have, we're going to set up 10 over 30. The shortest with the shortest. Shortest side on one with the shortest side on the other. That reduces to 1/3. And then we have the larger with the larger. So we have 11 and 33. Larger side over here with the larger side over here. And that is also 1/3. Fantastic. So these two match. That means we can say that CBA, let's see, C should match up with C. Let's see, since we lined up the 30 with the 10, the B should line up with the K. And since we set up the 33 with the 11, then the A should line up with the L. This was our similarity statements. Matching up our sides and angles properly. Triangle. By side, angle, side. All right, next. We are given angle E matching up with angle J. So now we just need to check the proportions. We don't need a reason because it's just marked in the diagram. If we were writing a reason, we would just say given. Now we're going to check our ratios. Again, shortest with the shortest. So 8 matches up with, what's the smallest on this one? It would be 18. and reduce that. Those are both divisible by 2, so we have 4 over 9. Okay, so we just need the other one to match to 4 over 9. Longer side here is 13. Going to match up with the longer side here, which is 28. Which doesn't reduce to anything. Uh-oh. Those don't match. Not similar. Those are not similar. The reason they aren't similar is because the ratios don't match. Next. Oh, let me write my methods back again so that we have them. Side, angle, side. Angle, angle. So those first two would have both used side, angle, side if we were doing them. We had the two sides proportional, matching up, and the included angle congruent. On 31, we're going to try and use side, side, side. Because all we know is the sides. We don't know anything about the angles. So we're going to set up some ratios. No, we're using that for angles. This color was our sides. So let's check. Let's set up. We're going to start with the smallest side, and we're going to set it up with the smallest side. So smallest side here was 6. We're going to match it up with the shortest one here is 20. 6 over 20, those are both divisible by 2. That's 3 over 10. Then our medium side here is 9. Medium side here is 9. We're going to set up with a medium side here, which is 30. See, those are both divisible by 3. 9 divided by 3 is 3. 30 divided by 3 is 10. Great. We're good so far. If this last one matches, then we win. I mean, then they're similar. I like to think of it as a victory for math if everything matches up nicely. It is pleasing when everything lines up in that way. They're both divisible by 4. 12 divided by 4, it's 3. Here we go. 4 divided by 4, 10. Isn't that nice? All right, here we go. Triangle. Let's see. S to T. Let's see. We want that to match up with the short side here, which is F to D. F, D, and E. Oh, no. Sorry. Other way. No, we want S to T. S to T is this side. So we want S to T. We want it to line up with F to E. My mistake. F to E. We want it to line up with the longest side. And then to D. By side, side, side similarity. Since all the sides line up. Okay, one more. We know angle K is congruent to angle Q. How do we know that? Because they're both 67 degrees. So they have to be congruent. There's our angle. And we also have another pair of angles, which are vertical angles, right here. So angle PJQ. That's this angle, being congruent to angle KJL by vertical angles theorem. So JKL, well, J should line up with J. K, what was K congruent to? Well, K was congruent to Q. So that's the order that we want. K should match up with Q, and that leaves L to match up with P. By angle similarity. We just had two angles congruent, and we were done. All right, next. Little bit more with similarity. Solve for x. The triangles in each pair are similar. Here we go. All we're doing here is we're setting up our proportions. So we have the triangles here are similar. The triangles that we have are this small triangle here, and then the entire triangle, which I'll put in blue here. All right, so we're going to set up the ratios of the sides, and we're going to say, well, if they're similar, then the ratios should match. Okay, so we'll match up our sides. Let's do, we have 18 here. We've got 18 over 66. Oh, let's actually reduce that. That's those are both divisible by 6, so that is 3. Sorry. Here, 3 over 11. 3 over 11. Okay. If you don't remember, this was called a scale factor. That was the ratio that all the sides should have. Okay, so 3 over 11 is my scale factor. And we were trying to solve for 11x. We're trying to solve for what this piece is here. Well, 11x is in the big triangle, so that means it's going to go on the bottom. And what's going to go on the top, we have... Oh, the matching sign in that triangle is 15. 15 goes on top. So just like we always did, we're going to multiply by what's on the bottom to get rid of the fraction. So on the bottom here, we have an 11x. So we're going to multiply both sides by 11x. And then over on this side, we have just 11. So we're going to multiply by 11 to get rid of the fraction there. All right, so 11's cancel here. So we have 11x times 3, that is 33x. Equals, the 11x cancels over on this side. So we have 15 times 11, which is 165. So we just need to divide by 33. And we get 5. So we get x here to be 5. So again, the process of solving these proportions, multiply to get rid of your fractions so that things cancel. Okay, let's do one more with these proportions and similarity, and then we'll go back to circles. Here we go. The idea here is that the pieces should match. The ratio of the pieces should be the same. So basically what we have for this theorem, for the way that we're going to set this up, is that piece over piece equals piece over piece. Right, the pieces on one side should match up with the pieces on the other side. So we have pieces here and pieces here. There we go. So let me make this a different color. Pieces there and pieces there. There we are. So the red pieces should line up with the blue pieces. So we'll do 20 over 7x plus 4. So that's your pieces on the red side. Then on the blue side, what we have is on the 20, the same side is going to be the 16, right? Those are the sides that kind of line up and are in the same spot. So if 20 goes on top on the red side, then 16 goes on top on the blue side, and then we have 20 going on the bottom. Fractions, let's get rid of those. So we're going to multiply, well, 20 is on the bottom on the right side. And then on the left side, what's on the bottom? Well, that's 7x plus 4. So we're going to multiply by 7x plus 4 on both sides. So on this side, the 7x plus 4's cancel. And we get 20 times 20 is 400. Equals, on this side, the 20s cancel, and we have 16 times 7x plus 4. So that means we got to distribute this out. Boom, boom. $112 x plus 64. So then we're going to subtract. And divide. 300 and that should be 336 equals 112x. So then we're going to divide. And we get x to be 3. And if we can plug in and make sure the answer makes sense, we have 7 times 3 plus 4. If x is 3, that would be 21 and 4 is 24. So 20 over 24. And you can check that those fractions simplify to be the same thing. All right, but the idea is that the pieces, we set up the pieces to be equal to each other. All right. We are almost done. Just a few more minutes. Stick with me. Here we go. We're on the home stretch. Okay. Here is our structure for an equation of a circle. X minus h squared plus y minus k squared equals r squared. So our center matches up there. And then this is where we get our radius. And I talked when we did these notes about how this is connected to what a circle is. Okay, but for now, remember that our center is subtracted and that our radius is squared when we go to do this. All right, so when we do this, our center here would be, well, what's subtracted? What's subtracted is a negative 2. Because this would have had to come from, if we wanted to put it in the form of x minus something, it would be x minus negative 2 to get x plus 2. So that means negative 2 had to be the x coordinate, and what's subtracted here is 1. So negative 2, 1 is my center. Let me go ahead and put that there. Boom. And our radius Our radius, remember this is r squared, so r squared is 16. So take the square root of 16 to get our actual radius, which is 4. So that means every point on the circle has to be a distance 4 away from that center. So let's go 4 to the right, 4 down, 4 up, and 4 to the left. And then we'll trace around a circle. There we go. We've made our circle. Done. Center here. Here, what's subtracted? The question is what is subtracted, and the answer is nothing. This would be x minus 0 squared. And then we have y minus 2, so 2 is getting subtracted. 0, 2 is my center. Oh, 0, 2. X coordinate 0, y coordinate 2. There it is. Radius. Radius, remember r is squared, so we need the square root of 12. Square root of 12. Which is a bit smaller than 4 and a little bit bigger than 3. So to kind of approximate, to kind of guess, we're going to go 1, 2, 3 and a bit. We're going to go up 1, 2, 3 and a bit. We're going to go down 1, 2, 3 and a bit. We're going to go to the left 1, 2, 3 and a bit to kind of get an estimate. Well, that's a pretty good circle. That's not bad. All right. One more. Actually, 2 more. I lied. There's 2 more. Okay. So let me erase some things. And then we'll finish up with these last 2. These last 2 are going the other direction. Where we drew the circle from the equation last time. Now we have the circle and we need to come up with the equation. So we're writing out the equation this time. Okay, here we go. We're going to do the same process. We're going to come up with the center, we're going to come up with the radius, and then we're going to write our equation. Well, it tells us the center. Done. There's the center. But radius is a little more complicated. How are we supposed to get the radius from the area? How is area connected to radius? Oh, area is connected to radius because area is pi r squared. So if we know the area, then we can get the radius. So if we know the area is 36 pi, then we're going to put 36 pi in for area. Okay, so that means pi r squared is 36 pi. Let's divide by pi. Let's get rid of the pi's. So that means 36 equals r squared. So we'll take the square root of both sides, and that means r is 6. Sorry, let me write that the other way so it's not confusing. R goes over here, 6 goes over there. So the radius is 6. Fantastic. Let's write that out. X minus your x coordinate squared plus y minus your y coordinate squared equals the radius squared. This is the part that stays the same structure every time. Now let's plug in our center and radius. X minus our x coordinate is 7. We have y minus our y coordinate is -4 squared equals our radius squared. Our radius we just found was 6. So let's write that out a bit nicer. X minus 7 squared plus y minus a negative would be plus 4 squared. Again, the negative is going to appear as the switch sign, so it'll appear as a plus. 6 squared is 36. So there's our equation. Last one. Center. Our center of the circle is right here. So let's see. That would make it our x coordinate be -2. And then our y coordinate being 3. And then our radius here. Our radius. Oh, careful, careful. This is a scale thing. The radius goes up from 3 to 4. This is a distance of 1. The scale might make it look different, but take any radius you want. This goes from -2 out to -1. The radius is 1. So let's write it out. Here's the structure that stays the same every time. Plus y minus our y coordinate center squared equals our radius squared. Oh, our radius was 1. Let's put that in. And then our center was at -2, 3. So subtracting a -2. And then we have y minus our y coordinate was 3. So then x minus a -2 will be x plus 2 squared. And then we have y minus 3 squared equals 1 squared is just 1. And there we are. All right. And if you're watching this, that means that we have made it to the end. All you need to do is take a picture of your work that you've been following along with and send it in to me on Canvas. And that's all I have for you. That kind of recaps everything we've done in the semester, both in person and in our remote learning. And I want to say again, I've said it a couple times, but I want to keep saying it. You guys who are sticking with me and have been doing all the work, it shows a sense of maturity and responsibility that is going to be so helpful for you to have. And sense of discipline that is so helpful later on in life. Even if this material doesn't stick with you, the skills you do to get yourself up and motivate yourself to work and to get through all this, even if you don't want to, even when you don't have someone looking over your shoulder making sure you're doing it, that is so important and so valuable. And I'm very glad that you're taking time out of your day because you feel that this is important. So, thank you guys for sticking with this. If there's anything else I can do for you, If there's any other questions, lingering questions you have, then feel free to send me a message over Canvas, over email, over Remind, any of that. And with that, I am signing off, and I will see you all around next year. Take care.